Morning. Finished. Actually started multivariate problems. A lot of stuff with multivariate functions works the same way. Evaluating f of -1, 3. Notice in the definition, f of x comma y. And the first term in the order pair is x, second term is y. Replace x with -1, replace y with 3. F of -1, 3 would be 2. F of -4, 2. Right, 4 to the 4th is 256, right? And then double that would be 512. Then f of -1, -3 is -4. Right? It's the same idea for more than two variant. Just have to keep an eye on the order in which your variables appear. Creating contour map. We're going to use technology for this. It's the contour block command, but we're not going to type in z equals. We're just typing in the function itself. Still need values for x and y. So I'm going to minus 5 to 5. That's what it would give. Of course, we can adjust some options. Make it look more like an actual proper coordinate system. Turn off the frame, turn on the axes. So each of those colors represents something. I think I can do this. It tells you the color scheme. So this light yellow up to that line is c equals 0. Right, so that's everything less than 0. Then between 0 and -10, it's -20 to -30, so on and so forth. Sometimes we don't want that though. Okay, just do this color. or shading none. I can also select the C values. Right, so right now all the C values are automatic, so it just automatically chooses the values, the scaling. That's the option. Contours is how many to use. Or what, yeah. So the contours are set to automatic. I can say, okay, I only want to use 5 contours. So it'll choose 5 contours, and again, choose them automatically. So it chose 0, negative 10, 20, 30, and 40. I can also tell it which contours to use. That'll just give me the 0 and negative 5. When C is 0 and C is negative 5. Doesn't let me get things set like that. Use those. You just have some fun with it. Can I put the labels on there? I think I can. Yes, I can. Doesn't really do the best job at labeling them, but you can get the labels on there. So I'm just going to stick with that being automatic, and I'll keep the labels on. Just copy and paste. Let's see what that gives us. All right. I'm not sure how I feel about that one. I'm going to choose mine for this one. see how that looks. Rid of that 30. That looks pretty good. Right now, what I could do is if I extend these out, go minus 10 to 10 instead. Let's keep going. Get a better idea of what's happening. The distance between them is starting to shrink, isn't it? As you go further out. Just get 175. Right, so in certain circumstances, you might be asked to do the contour map for certain levels. That's how you would do it using the contours command. That was 70.75. Oops. I wanted 70, 75. That's the one I wanted. There we go. So again, just have some fun with it. I'm going to do one more. This one's also a pretty interesting one. X squared minus 4y squared. I won't change anything else, I just want to see what I get. Okay. You put in the 0 as well. I think I'm just going to do by tens this time, though. Let's see why. Oh, I want the negatives. There we go. All right, so that just the x would be 0. All of your positive c's, hyperbolas along the x-axis. All of your negative c's are hyperbolas along the y-axis. That's a really cool looking shape. And I'll let you do that one again because that was boring. Actually, I did skip one, didn't I? 6. Domain. Right, so domain of a multivariate function, set of ordered pairs, right? So it has to be ordered pairs in R2, both x and y to be real numbers. Then all of your rules apply. So what do we know about square roots?
Can't be negative.
What can't be negative?
The variables.
So technically, we should be writing this. Set of all ordered pairs in R2. However, for this course, it is implied to be the real plane. So I can actually just ignore that. Right, I say implied to be the real plane because you can have something like this too. C2. That's all ordered numbers x, y, where both x and y are complex. So that would then include the i's. Right, and then there's also Z2, ordered pairs where each element's an integer. But we're implying to be R2. Let's say x does not equal 0, or sorry, x is greater than or equal to 0, and y is greater than or equal to 0. So we have to have both x and y being non-negative. I could write that a different way. So I could write this. That's going to get ugly though. Positive reals union with 0 to represent non-negatives. And so there's several ways you can do it to get your point across. Well, remember, that is a region in the plane, right? What region is that? So if I were to ask you to shade the region,
It's the first one.
just the entirety of the first quadrant in this case. So it's, again, a pretty boring region. It's an infinite square. Now this, I don't know why this is here, but whatever. Sphere centered at 10, 10, 4 with radius of 9. First things first, what is the standard equation of a circle?
2 pi r squared.
That is a special circle. That's centered at the origin. Where the center is AB. I believe that's called standard form. I don't think that's general form. Well, a sphere. Be the same thing, something like that, the z component, right? A hypersphere, you just have to add your fourth coordinate in there. Well then, this would be what, x minus 10 squared plus y minus 10 squared plus z minus 4 squared equals 81. What's 81 minus 216? Or 216 minus 81, let's move that 81 to the other side. There's general form. So either one would be accepted, unless I specify it. Domain and range. It's two variate, so it's a set of ordered pairs. What was the rule with square root?
Can be negative anytime.
Can be rewritten that way, can it? What kind of region is that? And so you have to describe the region, describe the domain.
It's the first quadrant.
Would it be opening down from 4? Or, no.
So ignore the less than for now. What's that?
That's a let's see.
Well, technically you're not wrong. It is an ellipse, but it's a special type of ellipse.
We literally just did it.
It's a circle of radius 2 centered at the origin. Close enough for government work.
It's a good circle.
So that's the circle. Now, what if it's less than? So x squared. So that's x squared plus y squared equals 4. What about x squared plus y squared less than 4?
It would just be inside.
Be everything inside, right? That would be the domain. Boundary included. That's why it's closed. So it's all points on or inside the circle of radius 2 centered at the origin. For the range, range is all the values that h of xy can be. Square root of 4 minus x squared minus y squared, what is the smallest value that can be? 8 minus 0 is 8. What's the largest value square root of 4 minus x squared minus y squared can be?
Oh, 4. From the domain.
So if you look at x squared plus y squared, what is the smallest that can be? 4 minus 0? Square root of 4?
2.
8 minus 2 is 6. And the largest x squared plus y squared to be allowed to be would be 4, right? 4 minus 4 is 0, root 0 is 0, 8 minus 0 is 8. Range is 6 to 8. Closed. Range is always a bit more of a pain. All right, multivariate limits. Here's the general idea. You want to use the properties that we looked at last time. Right. Difference property. Product. Let me do it this way. Limit of 2, that's the constant. Limit of x. We can just treat it as the limit as x approaches 3 of x, which is just 3. Power property. Then we have, of course, 7. Limit x squared. Limit of y squared. And now, of course, that's just going to be treated as y approaches 2. Two to the 5th power, 32. 32 times 3, 96. This one's fun. 9 times 4, 36. 36 times 7. What was it? Yes. And 96 minus 252.
156.
There's your limit, negative 156. And then I won't use those properties again. Direct substitution gives you the same thing. But that's why direct substitution works. So again, just like with Calc 1 limits, just try direct substitution first. See if it gives you an answer. So this one's a little bit different in terms of why direct substitution would work. The idea here would be to replace, so you break it down, you have the limit of x times the limit of that cosine, right? But now you have cosine of x minus y over 4. Replace it with z. What does x minus y over 4 approach as x approaches pi and y approaches 0? Is cosine continuous there? If it is, you can then use composite function theorem to pull the limit inside of the cosine. Right, so you have to do a change of variable first. But that would be the explanation of why you can just use direct substitution. Do direct substitution. d pi times cosine pi minus 0 over 4, right? Cosine of pi over 4 is what? Limits root 2 over 2 pi. happens if you do direct substitution here?
You get 0 right
What is that form called?
there. And it's
Bummer. That means we have to actually do some work. This is where the fun begins. Now you have to decide, do you think the limit exists? Actually, there's two ways I could go about this. I think I'm going to go a different route. See an x squared plus y squared. That's r squared in polar. Let's write this as polar. We're doing a change of variable. If xy is approaching the origin, that means that your r is shrinking down to 0. This will become the limit as r approaches 0. That's a problem. What this is telling us is the limit depends on the angle theta. It says it depends on the angle at which you're approaching the origin. The limit can't exist then. I can find two different ways to approach the origin and get different answers. So that limit does not exist. This is actually the same way that I did in my notes, where I just chose an arbitrary line y equals mx. It said approach that way. What you'll find is it actually depends on the slope of the line, which is what this says, depends on theta, the angle of the ray. happens. All right, we're approaching the origin, which means r is approaching 0. Now, limit becomes the limit as r approaches 0. What does the numerator become?
R squared cosine sine.
What about the denominator?
R.
That would become the limit of a half r sine of 2 theta, right, as r goes to 0. What's that limit? There's your limit. Limit 0. Now, to check, actually, let's call this f1. What was that first function? It was x squared over x squared plus y squared?
Square root of x squared.
No, the first one.
The one we did before. Oh.
Yeah.
Actually, can I do a multivariate limit now? I know that mathematics is updated. Oh, yes, I can now. That is so sweet. Of course, it only gives me indeterminate, which is lovely. What about F2? So this one was x times y divided by ta, that one. Okay, perfect. So it looks like if spits out indeterminate, probably a very high likelihood the limit doesn't exist. So then you just have to explain why it doesn't exist. Because that second limit should also give you indeterminate form, but it actually told me it's 0. That's actually a new feature. You actually used to have to do a nested limit. You have to do limit of, and then your function. What is your first variable doing, comma your second? I think it would have to be this. Used to be that. Now they finally built it into be multivariate, which is nice. I'm not sure if the calculator does multivariate, but I don't think it does. I think that you do have to do nested. If you want to check it on your calculator. As said, in general, multivariate limits are a pain to work with. You also have 3-variate limits, by the way. And we had 2 coordinate systems for that, right? We had cylindrical and spherical. So you could also convert to those in 3-variate. But the general procedure is the same. Got through that a lot faster than I thought I was going to. So it's going to take me a lot longer than that. That's okay, it's Friday. Second quiz goes up at 10:45. It'll be due Tuesday before class. Third project also went up yesterday, apparently. So I'll just mention it now. Third project is up. It's interesting. Yeah, let's call it that. It's interesting.
Let's do one Friday.
It's about a new swimsuit model, determining if it increases swimming speed. So maybe use the remaining 20 minutes to work on that. Get started, look at it. I actually don't know if you're going to be able to start it yet. I think you need partial derivatives, which we do Tuesday. But you can at least look at it, figure out who's in your group and all that. Otherwise, we start partial derivatives next week. And we're out of February already. And House Hunter Wilds came out today, so really wish work would go by quickly today so I can get home. Spend all weekend locked in my room playing it. Leave the kids to the life that weekend. Have a good weekend.